I know Java gets a fair bit of stick, especially from JavaScript developers, but I did a lot of Java development early in my career before moving primarily into JavaScript on the front end. And I think there's a fair few cool things that we could take from Java to make JavaScript a lot better. In this video, we're just going to be talking about a few of those things. Now, these things are all kind of semantics and tactical things, not real deep technical things. So just kind of day-to-day quality of life improvements. So let's get right into it. First up, let's talk about access modifiers. So in JavaScript, or specifically ECMAScript, there's essentially two ways to control the visibility, and that's with the export keyword. So if you use export, that means you're exporting this function, it's available everywhere. And if you don't use export, this function here is only available within the module, just within essentially the file here, right? So that's the only two ways to control those. In Java, what we have is we have a couple of extra ones. One of them I think is very useful. So let's look at the first two here. Public is the same as export. So this is what we have already. You have private here, which is just available in the same class. And then you have the third one here. This is when you omit any keyword, it's called package private. And a package is kind of you can kind of think of it as like a namespace of modules in JavaScript. I guess that's the equivalent. So combined with the directory. So essentially the directory might have a few classes or a few files. If it's package private, any one of those files can import it, but anything outside of that package or outside of that directory won't be able to import it. And I think this one would be pretty useful, especially the way I work on front end. Usually, for example, I'll have a components directory, and then within the components, let's say you have like a radio component, then I have different files within that directory, and I only want to expose them to the files within that directory. I don't want them to be exported outside of that directory. This is essentially what gives you that functionality. And in small teams and small code bases, it's not going to make a big difference. But when you get to larger code bases or larger teams, this avoids leaky APIs, it avoids bad abstractions, avoids people accidentally importing things across different directories where they shouldn't. There is a fourth approach here, which is protected. This one I never really used too much. This is basically the same as package private, but it also includes subclasses. Again, this is not going to be too useful in JavaScript because in Java it's a lot more object oriented. So there's going to be a lot of inheritance. This is what that means. Could be useful, but I think just the package one is one that I think would be very useful in the JavaScript world. Cool. So next up, I have enums here. So enums is something I used all the time in Java. A very common pattern. In TypeScript, I just don't find myself reaching out to it that much at all, actually. So yeah, let's just compare the two. So I've got enums on the left-hand side. I'll link a video to Matt's video about enums in TypeScript and a few of the kind of abnormalities that it has, especially that it's a TypeScript-only feature. It's not really a JavaScript feature, and probably just means that it's not going to be used that often. But here's an example here on the left hand side. Anyways, you have an enum of a role and enum of permissions, and then I've got kind of I want to model here the relationship between roles and permissions. So I want to model that a role has one or more permissions here. So you can just see that I've got a function here that just tests, if a role has a specific permission, and I'm just logging some of these out. So this is kind of a trivial example, but the thing I usually struggle with is here it doesn't really model the role the way I want to. And there's different ways to do this. This is just kind of, forget all the different syntax. It's just one of the approaches. Enum here, it doesn't really include the permission. So permission is a standalone thing in my mind, but if I was modeling role, I'd want to embed the permissions within the role here so that they're kind of tightly coupled instead of having it in an external map here. And this is maybe a bit of a common approach, probably without enums, but yeah, this is how you'd use enums in TypeScript. So I'll leave that where that is. Let's have a quick look at the Java side. So the slight advantage of Java enums is they're essentially kind of little classes, right? They can be used as singletons, which is a whole other thing, but you can kind of embed properties within the enum. You can add a constructor, you can add kind of private functions, and this is getting into the world of object oriented versus functional. But I do like that you're able to express what you're modeling a lot clearer in an enum. So you can see here I have the the permissions enum, which looks almost identical, so that's fine. But then the role here, I've got admin, editor, viewer. That's the same, and because I've got this permissions member here and the constructor, I can just pass that in directly with this syntax. So now this is kind of tightly coupled. You can see the relationship immediately between admin and the permissions it has. And what that means is you can just you can list the values of the permissions, from within the enum itself. It's got this instance that you can kind of play around with. It's got instance functions that you can kind of use as opposed to it, a pure function that you pass in. But I think I just really like the power that the enum gives you here to represent what you're trying to model. So next up is exception handling. So in JavaScript, there's not really a way to say that a function is going to throw an exception or an error, right? So you just kind of need to implicitly handle it. You can see here the example. We've got a custom IO exception here. I have a main function which I'm calling, and I've got these IO operations which are surrounded by a try catch. But the main thing here is, well, there's a couple of things. First of all, there's no feedback that these actually throw anything at all, right? So let me just comment this one out here. It will let you call it without the knowledge that this may throw. You can add return types in TypeScript, but it doesn't know, you don't know that it's gonna throw something and you don't know how to handle it. So that's kind of one aspect to it. And if I just uncomment all these, the next thing is you don't know the type. So you need to kind of do these runtime checks, instance of, and handle it individually there. The example here is kind of showing two exceptions that we should be handling. In this case, you just need to know that the function is going to throw, and you need to handle it. And if that changes, you need to you just need to know. And then there's a runtime error. This is something that you can't do anything about. That's fine. That should be able to run fine. So this is what that looks like. Now, there are some tools out there. I think Never Throw is one of them. I think there's different approaches, and they try to kind of solve this issue, but ultimately the language itself doesn't have that as a first-class citizen. Now, if compare that with Java, Java does have the throws keyword, and this basically allows you to tell a function that this is going to throw an exception, and if you have that, then you need to handle it. So if we look at commenting these out here, because this some IO operation function throws an IO exception, this is going to tell us, hey, you need to handle this. And there's two ways typically to handle this. This is going to be either you surround it with a try catch, or you're going to add it to the method signature. If I add it to the method signature, I'm essentially saying, all right, I'm not going to handle it in this function. Whoever calls this function is going to handle it. Otherwise, yeah, we're going to comment out this, and you'll see otherwise we just have the try function. The cool thing with this as well is you can see that this is of type IO exception, right? So we know the type here. If I go to this parent operation, which is just calling the child, this is just me showing that it kind of propagates up. I can add here, so this throws an IO exception. Maybe it also does a database query, so it could also throw in a SQL exception. As soon as I add this, it's going to complain. It's going to say, hey, you've handled the IO exception. You've not handled the SQL exception, right? And then again, there's a few different ways to handle this. If you don't want to handle it differently at all, you can just add SQL exceptions here with this syntax, kind of this union operator syntax. You can just kind of make this even more generic. So exception is a parent class of both of these. So you can say any exception, take it through this path. Alternatively, you can add a second catch. So I can go here and I can do another catch specifically for SQL exception. Now I've got another kind of code block to go through. So there's a few different options there. I like the way that this works. A lot of people aren't happy with the try catch syntax. I'm not too bothered about the syntax. I just like the handling or the explicit nature of handling the errors, and that Java forces you to it. So this is quite nice. Next up is method overloading. So method overloading, what does that even mean? So in TypeScript, you can't basically name multiple functions the same thing if they have different arguments. In Java, what you can do is you can have the same function, and as long as it's got a different signature, meaning it's got different arguments here, you can just, you can have those different functions, and the compiler will be able to differentiate which ones you're using. And on top of this, you can also have, I've got a string variable here, log message, and I can just log that out, right? Log message, and the compiler is going to know this is it's a value, it's a string, and these ones are functions. It's not going to get confused about it, and it knows. So I can see here, as soon as I click on the first one, it knows that this must be the message because it's the only one with a signature that just has a string. It knows that the second one is the second function here. And it knows the third one is the last one here. And the way I usually use this in Java is I'll have kind of one function that handles the actual logic. So you can see the logic inside here. This is just printing some text in different colors. You've got the log level here, but this details there. And then what I usually do is the other two approaches is, well, what if we don't have all the different arguments? So we can have essentially you're providing defaults. So this is just a message, and we're just gonna propagate this to the main function with a different default. In this second one here, you're taking in the code, you're gonna convert it to the level, and then we're gonna pass it into this main function. So this is kind of a way of providing default arguments to functions. And you can see the JavaScript alternative. So there is kind of a way to do this in TypeScript with this syntax, where you have your different arguments here, and then you have your main function. The annoying thing, again, with TypeScript is the main function then needs to know all the different variants. So because the first argument is always a string, that's simple enough. It's a string here. But the second argument, it could be a log level, which is just a union here, or it could be a number. So our log message needs to take both of those in, and then it needs to runtime check. So it needs to do a runtime check, which type is it, and then it needs to delegate. You can see how confusing this might get, or how complicated this might get if you have lots of different variants here. The other option, of course, is you just give them all different names, and then you delegate. And of course, I couldn't then have a constant value with log message, and that's of course because, well, values can be functions as well, right? So this could just be a function. So we couldn't have, the compiler can't really differentiate in this case. And the final one here is just the collectors API. So this is again another very just syntactical thing. In fact, this is completely solved by tools like Lodash, etc. But this is a built-in thing in Java. So with Java lists, same with JavaScript lists, they both have your kind of usual functions to manipulate them. So you've got your your map, your filter, your reducers, etc. But Java's got essentially a bunch of kind of helper functions when it comes to collecting or terminal operations, and we can kind of see them here. And this is all kind of exposed via the collectors interface here. So I have a bunch of collector imports here, and we'll just go through some of them just now. So what I've got here is I've just got a list of students. So you can just see here, list of students on the left, list of students on the right. They look exactly the same, and we're just manipulating the list of students. The first three here are essentially just basic collections, right? So I have the students, I want to group it by the grade, right? So that's just, in Java, you're usually going to convert this to stream. Stream is the way we manipulate lists. And then we're going to use this collect. This is the API that I'm talking about. So this collect takes in a collector, and there's all these different types of collectors. So the first one here I'm going to say is the grouping by. So we want to collect it. Well, how do we want to collect it? Well, we want to group by the student grade. If you're not familiar with this syntax here, it's just a method reference. So this is just if you've got student and then a lambda student.grade. So if you're just accessing a property of the single argument, you can just shorten it to this method reference. So that's all that's doing. So this is nice and simple. So if you wanted to then kind of expand on that, let's just say instead of just students by grade, and this will essentially give you, I think we can see the output here. This will essentially give you the grade and then a list of each of the students. So we can just scroll up here. So yeah, we have A, and then we have a list of the students here, B, list of the students, etc. Well, let's say you didn't just want the list of students, you wanted the list of student names. So you want to then further map the resulting list into just the names there. So what you can do is, again, you start off the same way, grouping by student grade, and this grouping by just takes in a second collector. So this mapping here is just a second collector. We can just use this collector right here as a mapping by. You wouldn't actually do that because there's you can just use a dot map. But yeah, so there's another collector called mapping, and then so we're grouping here by student grade, and then we're mapping the results into student name. And this here shows a different second collector. So instead of mapping the name, you're just counting. So I'm just going to say how many for each grade. So this will have A, then it'll have a number, and this just does counting because it just counts the number of elements. But there's other collectors. So if I do collectors, if I spell that correctly, you can see all these different collectors here. So for example, if I wanted to do some other count, I can say, well, collectors, let me give a summing in. Let me sum a bunch of integers. Which integer do you want to sum? Maybe the student score here. So this will just give you the total score per grade, things like that. So this is quite nice. So the first three here are just represented by the first three here on the left-hand side. These are just reducers, and you can see the kind of standard logic. You're just doing a check against the existing map, and then you're either adding it, pushing it, or you're setting it depending on the grade. So it's worth noting that Object does have an API for this, but it's just for the simple kind of the initial scenario, which is just a simple key and then grouping the items there. If we move on to a few other things, so you've got things like joining all the elements. That's very similar. Converting to a set, again, you can collect it to a set. Here, this is the JavaScript way. You can, again, do the exact same. You can also use the new set syntax. There's a couple of different ways. Java has a nice summarizing int one, and this basically gives you some statistics. So if you ever have the need to exactly want, count, sum, min, max, and average, the Java one's going to give you that out of the box. And this is what it looks like in JavaScript. And the final one is essentially just a partition. So if you want to partition by Boolean, so you pass it in a predicate, partitioning by, passing in the predicate, it's going to give you a map of true and false with the different values. And it's worth noting, these are very simple operations here. These are all just, it's a reduction, it's a reduce operator on a list. But of course, you can chain all these. You can chain the map, filter, sort, etc. And then you can collect it at the end. And then even when you collect it, you can then further take that and, chain on other Fluent APIs. So I like the kind of the APIs, but I also just like the general approach, the functional approach, and the Fluent style APIs here too. Cool. So So I think that's everything I wanted to cover in this video. Just a few things that I wish JavaScript had just to improve the day-to-day ever so slightly in terms of kind of semantics or syntax. So I think I'm going to wrap it up there. Thank you very much for watching. Have a good day, and I will see you in the next one.